Hi there, so we're going to start off and just look at the build for version 2 of the RadioLab. I'm going to try to keep it with a minimum of tools and test equipment. So what do you need? You need soldering iron, hopefully self-explanatory, some solder, possibly some braid. Not 100% necessary, but does make things easier. It's flux. I have a wire strippers, and I have a pliers, and tweezers. So that's what we'll attempt to build it with, and we'll see how we get on. If we need to add in anything else, we'll do it as we go. So this is the board as it comes. It has two edge pieces here that are used in manufacturing to put fiducials on them. That's the underside of the board. So there's a lot of stuff built, but there's still a good bit of building to actually do. So I'm going to start with the power supply, and for that, I'm just going to attach a couple of wires to it. I hope the video is clear there. So we'll start with the positive and negative. So I have a power supply, and it comes onto these two crocodile clips here. Depending on what you're doing. I'm just going to do this temporarily. So I'm going to cut the wire to about a foot. Or 30 inches, depending on where you are in the world. Or sorry, 30 centimeters, I should say. So we'll do that for the black and the red. Let's move them out of the way, and then we will we'll strip these. And I'm going to tin them. I'm not sure if this is. So we'll tin the wires. And I'm just going to change my glasses here. Yeah. Okay, so. So we'll tin those two, and then these two. Or this side, I should say, I guess. Oh, probably have back of my head there in the video. So this is the practical side. I will go through the actual circuits and so on. So we need to attach these to the power supply input. For this, I'm using an old box that I had, but if you want to build the enclosure first, you could do the exact same method. It's just handy for leaving this thing rest on it. So hopefully that's, yeah. So we want to just put a little bit of flux on, and some solder on the ground and the V in. So, you know, it's 12 volt, 13.8. It does work outside of those. I definitely wouldn't go much above the 13.8. Avoid it if possible. There's nothing really there that should blow, but just in case. Oh, that would have been a good test for the circuit to check for the reverse voltage. So we have them powered on, or them soldered on, and we connect up our power supply here. So we'll go positive to positive, negative to negative, and let's power it on. Let's see what happens. And we get liftoff. So I always dread doing this, but I'm now going to reverse the power supply because there's power supply protection in this. So I'll put the ground to the positive and the red to the negative. I've done this many times and I'm still scared. And okay, good. So reversed polarity should happen then. So that's the power side of it started. I'm just trying to. Sorry, yeah. So just let me. Okay, so I've just put them back in the right way. What I do advise on a new board, don't have to do it, but if ideally you're going to have at least a multimeter, is just to check some of the voltage regulators. I won't be showing this on the screen, but I will be checking it myself. So we should get 3.3 volts here, and I got 3.334. We should get the same up here. And I get 3.47, and we should be getting 5 volts here, and I'm getting 5.1. So that's all good. Just to make sure that the regulators are the voltage throughout the board is as it should be. So now that we got the system powered up, the next stage is to look at the audio and just to insert the amplifier and test that. So now we're going to move on to the audio section, and for that we will have the audio amplifier, 3.5mm phono jack, and some jumpers. So let's start with the 3.5mm audio jack. So I'll just put this guy in. And try to do this without scraping the board. Okay, so then we got this guy in here. Actually, I don't like the way that is, so let's move this 90 degrees, and then I tighten it up when it's in. So the connections to make is, if I can show this up close and personal. So from this terminal to here, so the terminal on the bottom, and then from this guy to here. So let's connect them up. The output of this is floating, so it's not referenced to ground. So we'll just get two short wires with my wire cutters. So just we'll make two of these. And we'll just strip them and tin them the same as the power supply. So I'll just put them on the edge of the box there for now. A vise might be more applicable, but I can't get the vise in or into the picture, so we'll do it this way. Okay, and just going to trim them a little bit. Okay, and so we're just flip the board around this way. Bring it over closer to me. Again, I built these without ever using flux at times, so it's not absolutely necessary, but it is good practice. So we'll just tin all of these. And connect them up to the speaker output on the board. Okay, so that's the phono jack. So now I'll put in the audio amplifier, which is here somewhere. So this guy goes in on the underside of the board, and just like that. Now the pins are sticking out a lot here, so rather than having to trim all the pins, what I'm going to do is I'm going to push it back in closer to the board. Then there's no necessary to trim the pins after that. So we'll just put in one. We'll solder one pin, and let's get that guy pushed right back in. That looks pretty good. Just solder another pin here. And then just have a look, make sure that's reasonably square, which it is. So I'll just go ahead and solder all the rest of the pins now. Should have probably used flux on this one. It works either way. I won't clean it straight away, but I'll give the board a good clean when it's all finished. And that's another tool actually, I should have mentioned. Some kind of brush and IPA just to give it a good clean when you have it complete. Okay, so that's the audio amp are soldered in. So you can refer to the schematic, but there's a couple of different stages of this. So the normal way of doing it is that we have a preamplifier, and then you can, if you wanted to use an external without preamplifier or do your own preamplifier, excuse me, you'd connect a jumper here. But for using in standard configuration, you connect the preamplifier to the main amplifier. So on the mute select, so basically if you're using if you want to make a transceiver, there's a mute select input into it. So you can go external or internal. We're going to go internal because we want it to be enabled. And for now, that's all that we need. So I'm going to just plug a speaker in here. If you don't have a speaker with a connection like this, you can connect directly to these pins here, or you could connect to the back of the board and bring the wires out here if you felt like. But I think using something kind of standard mono jack is the way to go. So let's power this up. We can hear something on the speaker, and by putting your finger on this, you should hear the mains hum, and that tells you that it's working. So we'll just quickly test the low pass filter. You can see it gets rid of a lot of the high frequency noise. And that's the audio section except for the knob. I won't put the knobs on just yet. And then we're going to move now to the next section, which I think will be our microcontroller display encoder portion. And we'll get them up and running. So for the controller section, there's three main components. Encoder, ESP32, and the display module. So we'll start with the encoder. And pins are a little bit bent. So and it just fits in like that, and then we can solder it at the back. So let's do that. Try not to forget to flux this down. I'm not sure it's going to make a lot of difference on this guy. That's the main tabs. Just make sure the encoder is in correctly, and it is. So let's solder in the encoder section and then the switch section. Maybe it's the light, that doesn't look good to me. This particular guy for some reason. Let's see. Okay. I'll clean that up. And just see that the solder make it through the other side. Not on the middle guy. I'm just gonna, not sure why that's not taken, but I'm just going to put a little bit of solder in this side as well. And okay, so that's the encoder in, and then we just need to put in the display and the ESP32. So we take this out of the packet, and you can go by the tab here, should match the tab on this guy. So just simply plug him in there and take our display. I'm going to get this out of the packet. It's probably easier to tear the packet the other way, but let's see. So I'll leave the protection on it just for now. So that's display, and we can simply just plug that in there. What I will do is, I won't do it right now, but I will put 4 pins here so that it actually sits up straight. I won't do that right now though. So that's the that's that part built, but I'd like to run a test on it. So basically, there is a section there on setting up the Arduino software. So what we need to do is just simply download a program to this. So I'm going to do that and just make sure that it's functioning okay. Now, so I have downloaded the super heterodyne radio sketch into the ESP32 and I turn it on, and don't be alarmed when nothing. Oh, sorry. I thought it was going to time out waiting for the variable frequency oscillator I2C. Okay. It did when I programmed it. It took a while to come on when I had the cable in, so I'm not exactly sure. Oh yeah, it's sorry, because I wasn't part of from the 12 volts. This wasn't active, so there was a delay there. But basically, you should see something come up on the screen. If you change the encoder, you should see the frequency change, and that switch was meant to increment this from what I can remember. Just have a little look here and see if there's something obvious. Well, solder joints seem to be fine. So I'm not going to debug it until I put the crystal in for this guy. Because the encoder is working, just the switch isn't. So I have to figure out why. Okay, so we'll put the crystal in for this variable frequency oscillator next. Okay, so this is the crystal, and he's inserted here. Even though it is surface mount, it should be a very easy one to install for anybody. So just put a little bit of flux here, and tin one side of this. So it's a 25 megahertz crystal. And we'll do the other side. Okay, so that's in there good and tight. Just thinking here out loud, I think that I may have put in a sketch that is for the version 1 of this instead of version 2, and that's why the encoder switch isn't working. But let's just see. So now, if you have an oscilloscope, this is a good time to probe these guys. If you don't sweat it. I'm just going to do it here myself to test this. And make sure that I'm getting the frequencies out that I want. There is a calibration required for these if you want to get them exactly. Not necessary at the moment, but it's because every crystal is slightly different. So I'm just going to check these on the oscilloscope, make sure that they're working, and then we'll go from there. Okay, so I've just checked these two, and this one is approximately, it'll be the sum of these, which is 16 point something megahertz, 16 point. Let me just reset it back to factory. So it's going to be, it's reading on the scope, that's reading 9.211, and this, right. So both reading 9.211. Let's see, I just change that, and sorry, I was looking at the wrong thing. So it's reading about 6, let me just, from power on, it's reading 16.33, and this is 9.211 megahertz. And so I just adjust this, just make sure it adjusts up as well, so it's 16.45. So that's fine, that's working. I will have to look at the switch here. So I have a feeling this is to do with the differences between the versions, but I'll come back to that, and I'll make sure that in the written instructions that it tells you the exact sketch to put in, and we'll do exactly that. So what have we got working? So we have the power working, the audio section is working. This appears to be working, but as I say, I think I have the wrong sketch, and the variable frequency side of it working. So the next stage is we can pick something. There's some coils to be wound for the IF filter and the RF filter. So we might tackle the RF filter next, and yeah, and then we can adjust the spectrum analyzer side of it as well, so that we can use that to actually adjust our RF filter. So let's do that. Okay, so before we move to the the RF filter. I actually just checked the sketch, and I had commented out the code for reading the coder. I was doing some experiments with it on a different date. So on my local system, it wasn't up to date. But once I just put back in that code, it's fine. Okay, that's good. So as I say, we'll move on to the RF filter side of things next. So for the RF filter, we have two T50-6 cores and two variable capacitors. Again, another tool I forgot to mention that is quite important. And this guy is damaged, but I have some more. Is a non-metallic screwdriver for adjusting them. You can do it with metallic, but when you put it in, it changes, and you have to. It's a little bit. It's messier. But if you don't have one, you can still do it. So what I'm going to do is I'm going to wind the coils. So there are 6 turns on the primary and 19 turns on the secondary. So I'm going to get the coils wound, and then I'll show you them, and then we'll insert them into the back of we'll insert them into the back of the board here. And we'll test the RF circuit, and then we go from there. So I just said I'd stop here for anybody who's not familiar with winding coils. So let's have a look at this. So every time the wire goes through the core, it's counted as a turn. So that's 1, 2, 3, 4, 5, 6. That's 6 turns. So I'm just going to put 19 then on this side. Okay, so that's the coil. So we have 6 on one side, 19 on the other, and it's going to go. They're going to go in like this. So we can trim them pretty tight. And another tool that I should mention is a sharp knife, just to scrape off the enamel off the wire. So I'm going to trim them and scrape that, and we'll get it soldered in. So just want to really emphasize how critical it is, just to make sure that the ends are well tinned. The enamel on this wire is, some enamels just burn off. This one doesn't. So if it doesn't, so you can see there, I haven't scraped the enamel properly on. I don't know if that's clear on this guy. So I'm just gonna do that. So it's worth spending time. Just make sure that the enamel is all off the wire. Save you a lot of debugging later. Okay, so that's the first guy, and I'll put both of them in shortly. Make it nice and neat. So there is holes for these. I don't actually use them, but if you wanted to put a plastic screw through that just to lock them in position, you could do that. That's what it was for. I haven't been using it, so it's up to yourself if you did want to. Okay, so now we got our two coils wound, and so the 6 to 19, 6 on this side, 19 here, 19 here, and 6 here. So I'll do the 19 side first on this one. And we'll just put it in, then we'll arrange the wires to make it nice and neat after. Okay. I can push that over there. And actually, tin these two guys first. I hope somebody shows off this when they've done it in a really, really neat way. I'm probably not the neatest. So let's see. So now, see if we can tidy this up nicely. Left-hand soldering here, so that's not good. Okay. So that's that guy. Let me do the second one. This capacitor is intentionally left out. It's not needed. But if you wanted to change this to a different band, you could use it. So again, we want 6 on the outside and 19 on the inside. Not happy with that now. Okay, I'll touch that up in a minute. Yeah. I probably should have cut this bit. I don't actually do video editing. I'm too lazy. So I just stop and start my phone. Okay. So we got our 2 coils in. And now we need to put in the variable capacitors. So we'll get these guys in. So let's turn over the board. And so the flat part of the capacitor goes to this side. And so there's different techniques we can use here. Some people use blue tack, and I think that works well. Sorry, just looking for my knife. I tend to use black tape. So we'll just put that over them, and then we'll solder one side of each. Make sure they're seated, and then we do the second side. Okay, so just make sure that they're seated properly, and then we'll do the opposite side. And they are, which is good. So something I hadn't used before, actually, until I started using lately, is this brass kind of not filings, but I'm not sure what term, but it's really. I used to use the sponge, and a wet sponge, but this is a lot better. It doesn't take the heat out of the soldering iron either, and yeah, much preferred. Okay, so that's the RF filter done. So what we're going to do now is we're going to try to align this using the inbuilt spectrum analyzer. There's code up on GitHub, or if there's not, there will be. I'm pretty certain there is. I've put it up already. So if we take the output from an oscillator here, so I'm just going to connect this up here, and we connect it to the input of the RF amplifier. Then we take our output from the RF amplifier and into our poor man's spectrum analyzer. I shouldn't actually call it spectrum analyzer. It's not really. It's a very poor man's spectrum analyzer. But it does actually show you the spectrum of what you're looking at. So I guess it is technically a spectrum analyzer. And the output of this then goes into the A to D here, which I think is V in, but I'll check that. So the principle behind this, and I'll program this up in a moment. The principle behind it, so we put a clock out here, and we'll sweep it from, maybe 6.8 meg to 7.4 meg, something in that. I can't remember the exact numbers I was using, but I'll come back to it. So the RF filter should allow this is a square wave, but the RF filter should allow signals that are we're going to go from 7.0 to 7.2. If you're in a stage, you might want to go to 7.3. Are centered in the middle of the two. I'm mostly interested in the CW start of the band, so I'm really conscious of getting the bottom part right, more so than the top. So any signals outside of that should be attenuated. So we take the output, feed it into the spectrum analyzer, and it's basically it's a AM demodulator. So we just have a diode and capacitor to demodulate the signal. One thing that is actually quite important is to make sure we put a 50 ohm termination here, or that can throw things off drastically. So I'm going to program in the spectrum analyzer into the ESP32, and then we'll go ahead and we'll align the RF amplifier. Okay, so we're going to look at the spectrum analyzer. Start off by just setting that up. So I did make a mistake where I said it was VP, or VN, it's actually VP. So the out from spectrum analyzer goes to VP. So I've loaded in the spectrum analyzer code into the board, and we'll just turn it on. So at the moment it's set for 7 megahertz with a span of 2 megahertz and a gain of 10. So I'll explain those. So right now, the pot when it comes, it could be anywhere. So we basically need to set that to around 0.7 of a volt. The easiest way to do it, so if you see a blue line up here, then you know you're at the max. So that means the voltage is too high. So if I just gradually lower that, we should see that drop. So you can see now it's scanning across. And the only alignment we need to do is bring that down to the very bottom of the screen, where you can just barely see some pixels coming across. So it's basically scanning across, and spectrum analyzer is aligned. So let's put this in here, and I just remembered something. The turns were wrong, and it's going to be pretty obvious soon as to why. So so basically you can change the marker, the span, or the gain. So on the span, I'm going to go higher. So let's say I'm going to go to 3 megahertz or something. So this is the response of the filter right now. But we can see if I go back to my marker and go over here, we'll see it's up around 8 megahertz for the filter. And I believe even if I change, no, as soon as I saw this I realized I had to change the turns. So if I move this, I can peak it, but we're not changing the frequency significantly at all. And it's just the other one. So we can move it down, but then our peak gets all over the place. So so it's down to 7.6. Now the actual number of turns was 21, not 19. I made a documentation error and I repeated it many times now at this stage, unfortunately. So I need to fix that. But the good thing is this is because it tells you exactly what's going on. So let me sort those coils out and I'll come back. So now I've just rewound the secondaries of those coils, and we can see we're getting a lot closer to where we need to be. So where's my adjustment guy? So we just do some adjustments here. I'm going to bring the span down. Actually looks pretty good as it is. Just put the gain up a little bit so we can see. But that looks pretty much bang on. This is a linear scale, so a dB or so you will start to notice it more so than you would on a dB scale. Yeah, that's just moving the frequency up too much. So yeah, so I'm pretty happy with that. So we're at 7 megahertz there. If I go to the marker, yeah. Again, it's a linear scale, but for me, if you're more interested in SSB, then you might want to adjust it slightly differently to the higher end of the band. especially in the US if you're up to 7.3 meg versus 7.2 here. So I'm happy with that. And again, if you have a spectrum analyzer, all you need to do is basically put your spectrum with a tracking generator, put a tracking generator output here, the spectrum analyzer here, and adjust accordingly. But this will get you in the ballpark. This is the type of peak that you're looking for. So, let's say for the spectrum analyzer, when you start off, adjust it counterclockwise all the way, and then gradually bring it up until you get a straight line here. Then connect your clock 1 output to our RF filter. 21 turns. If you want to be really cautious, maybe put 22 or 23 on it, and just adjust and just take the turns off just to be sure. I don't think you need to do that, but if you don't have any spare wire, it might be a good precaution to take. Okay, so we now have our spectrum analyzer working and our RF input filter working. So we could possibly at this stage just go for the direct conversion receiver, and see that would test all of these sections here, a mixer, and the audio out. So I think we'll do that, and then the last thing we have to do is the IF filter after that. So we'll do the direct conversion receiver next. So now for the direct conversion receiver, we basically, I'm just putting the aerial in. So that's going through our bandpass filter. I'm bringing it through a gain stage into the mixer. And then the output of the mixer. So on version 2, I'm trying to minimize the number of cables that we need to use. So this kind of things that are normally connected, you can just connect with jumpers. So our output from the mixer, by putting that jumper there and this jumper here, will bring it into the audio automatically without the need for cables on it. So this jumper here, this jumper here, let me get my speaker. So now I've programmed in the sketch, connected the aerial, and nothing. Wonderful. Let's see what's going on here. Sorry. This jumper should be here. That's what actually connects the output from this to the audio. So let's get rid of some of the high frequency noise. So, if you've got this far, you've made your first radio on the RadioLab, and let's see if there's any SSB on. Some German stations. I think that's FT8. Not sure what that is. So it seems to be mostly European guys at the moment. Okay. Anyway, we won't dwell on that too much. Oh, I forgot something. There's a mod. There's one mod needs to be done on the board. So when you hear this, I'm very stupidly messed up in the design from the pot to the input to the pot, or from the pot. Yeah, I didn't put a capacitor, so the pot is connected directly to the base of the transistor rather than through a capacitor. But once we put a capacitor in there, that'll fix that just fine. Um, so and that type of noise will just go away. It'll be perfectly quiet. I thought I had got a batch of bad pots when I first tested it, but it wasn't. So thankfully, that is the only mod that needed to be done to the board. Because when you're doing small ones, you can't really afford to get a load of brand new boards. If I was doing 10,000 of these or something, yeah, that would be a different story. Okay, so we've got most of the thing working. Realistically, the only thing that we've left to build is the IF filter, and then we just test that and the variable gain IF amplifier, and we should be able to make a superhet. Then we can add in the different modules, the SDR, the universal radio, the CW transmitter. But we'll finish this and then we'll look at building the box. Okay, so here's the components for the IF filter. So we got 4 crystals and 2, what are they called? FT37-43. And these are 4 to 8 turns ratio on both of these. And I have double checked it. I'm not doing that one twice. So I'll go ahead and wind the coils and we'll put the crystals in, and we'll come back after that. Okay, so I've got the coils wound, and we'll just install them, and then we'll test our superhet and see how that goes. So again, the input is 4 and the output is 8 turns. So that's the arrangement there. So let's put some solder on these pads. So now there seems to be a bit of not as clean as it should be. Okay. Ooh. Okay. Okay, one done, one to go. Just for these are impedance matching transformers, so to match 50 ohms to the impedance of the filter. So now, okay, so there's the two coils in. So let's put in the crystals. Now there is fission to ground the crystals and solder them. I haven't found it necessary, so I haven't done it. But these are two ground points. If it becomes necessary, it's an easy thing to do. And you may wonder, why am I not matching the crystals? And the reason is simple. I've tested, I bought these and they're really high quality crystals. I got them from Mouser, and I went through them and they're all pretty much an identical match in frequency. So any one I've built so far has been 100%, and without the need to match them. Oh, snips, another tool that is needed. So I'm just soldering one side of these just to hold them in position. And once that's done, we'll, yeah, perfect. Okay, maybe we'll adjust it just a little bit. So, I like to get these lined up and looking good. That looks pretty good. Okay, let's solder the opposite side. Now, you can, if you want, modify the, I won't trim them just yet, but you can modify the spectrum analyzer and run that across this. It's not really necessary, there isn't much can go wrong with it. So that's the RadioLab pretty much built. So the difference between version 2 and version 1 is version 1 you'd have to put cable from here to here, here to here, this to this, this to this, and so join them all together. So for version 2, what I've done is I've added in jumpers, and you can see these dotted lines. So this will take the RF filter, goes into the mixer. From the mixer, it goes out to the wideband RF amplifier. From the amplifier, it goes into the IF filter. From the filter, we go into our variable gain amplifier. And we go from our variable gain amplifier out into our, again, a double balanced mixer. The output of that goes to the audio. That comes here and out. Then we want to get our local oscillator from here to here. So there's a track running along the board all the way up to here. So to do that, you just put in a jumper at both sides, and that joins them together. It just means that if you're doing experiments where you want to put something in, you don't have this big long trace by lifting the jumper. The same for this mixer. We just have to join it here. And I'm probably missing something, but I think the only other thing we need to do is on our IF amplifier, because there is provision there if you want to add in some automatic gain control. So there's external and there's the pot. So we want to control the gain by the pot, and the pot is this guy. So we just put this in here. So I need to reprogram this with the superhet code, and we'll give it a test. Okay, so I have I programmed in the superhet design radio sketch. So let's just connect up the aerial here and the audio out, and cross a couple of fingers and toes, and hopefully I haven't missed anything. Let's see. Ah, okay. So this will test the IF amplifier. Oh yeah, we still have to do the mod for stop that bad sound. Okay, so superhet drone is working. There is alignment features, to calibrate the VFOs of that, but I'll do a separate video on those. There's a contest I should say on. So, okay, so the last stage, there's a couple of more little things to do, put some knobs on the pots, to put in some hardware here so that we can do our plug-in modules. Put a what you call it, a breadboard, stick it down here, and just that one mod that needs to be done to the system. So let's get the knobs on. So for the encoder alignment, or it doesn't really matter because it's continuous. No matter what way you go, it's going to be the same. So for the IF and the audio, just to have it nicely lined up. So and it's pretty much self-centered. So that's 0 and that's full. And the same with the next one. So 0 and full. Okay, shouldn't have changed the performance a whole pile, I hope. Okay, and so the last one thing we need to do is on this, fix that horrible sound on the when we move the pot. So to do that requires a little bit of surgery, nothing crazy, but it does require a little bit. So basically, I forgot to put a capacitor between the center of the pot and this is the base of the common emitter amplifier. So what we can do is, there's a little track there which we will cut, and we'll just put the capacitor in this position here. It'll fit pretty nice. So I'm going to cut the track first, and so I'm just using a sharp Stanley type knife. So I'm just going to check that with a multimeter, make sure it is. So the connection between this resistor and the center should now be open. Yes, or it's 2.5 kilo ohms, but it would be short if this was connected. So what we shall do is insert that capacitor. Okay, some really strange reason I can't lay my hands on the steps, but I'm just going to put it in, and I'll tidy it up later, just to basically make this complete. So we want to have the capacitor, the negative side going to the center of the pot. And not short the pot, which is exactly what I've done there. So I'll just solder this side and then I'll come back to the pot. So let's get a little bit of solder braid and hopefully clean this up. And that looks like it's done, but let's check. When I in my youth, I attended plasterers, and we'd be cutting drywall and what have you. I have it drilled in my head, been over that, measure twice and cut once. So, so here, input, sorry, now. So that's short. Let's check here. That's measuring 2 ohms, which doesn't sound right. 10 ohm, 10 kilo ohm, 9 kilo ohm. Is it that the pot is turned all the way down? Let's put the pot all the way the opposite direction and see. And now it's measuring 10 kilo ohms. Okay, so there's no short there. So let's just make sure that that has fixed the scratchiness. As I say, I'll tidy up the wires once I get my hands on that snips somewhere or other. So let's just put back in the aerial antenna and the speaker. And there's a scratch. Scratchiness is now gone. So that's sorted. So okay, good. Almost there. So we just need to do the hardware bits here, and let's get that done. And actually, just before I put in the hardware, I just want to put in this connector here. So I put the connector in the socket, and that way it'll be guaranteed to be perfectly aligned after we solder. So let's just get this guy done. Okay, so now that's even and solid. So I'm going to get the hardware bits for this, and then we will get that done. Okay, so what we're doing here is we're going to put in these inserts, and then we're going to do a nut, a lock washer, and a standard washer, if I'm calling them the right things. So what we're doing is we're going to just put this up on its side. So for each one, the first thing we want is a large washer. If this is coming out. Where is it? Okay. So if that, next is the lock washer, and then the nut. And these standoffs are simply for putting the additional boards on. So again, the washer, the lock washer, and the nut. And the washer just protects the board from the lock washer. It will damage it if you don't put the washer on. So I'm just hand tightening these. I'll tighten them fully in a moment. So wonder if I can do all 4 in one time without falling out. Let's see. Not sure how good or bad this is coming out on camera. but hopefully if it's not great, you get the idea. And all the screws, nuts, everything are all in metric. We don't measure things in bananas. I'm just kidding to all my American friends. I see a lot of memes going on about, how things are measured in bananas, every sort of unit. That doesn't make sense. I lived in America for 3 years, so I did actually understand all the different nut sizes, screw sizes and everything. But I've forgotten them all again. So we keep it nice and simple. M3 is 3 millimeters. So just give these a little bit of a tighten now, and okay. I think I forgot a lock washer here. I did. Probably somebody screaming at the video. So let's put that in. Okay, they're just hand tight at the moment. Good to do it from both sides. I'm not going to do it now and waste your time. So there's only one last thing to do, and that's the breadboard here. So I'll go get that and we'll put that on. So this is the breadboard, and it fits nicely in here. I would advise keeping it over a little bit to the left just to keep this hole clear, because when we mount it to the case, it will it will allow the screw to go in. It's self-adhesive, and I'm not going to stick it now because I do want to give this whole thing a clean. And it also still allows, you can still plug in your modules into here, even with the breadboard. So if even though it's stuck in, it is out of the way, unless you have some deep components in the back. So that's it. We need to just break this off here. Obviously, there's a few things that have to be trimmed. Have to get the what you call it, snips out, and that's it. So if you've got this far, a big congratulations. You've now succeeded in building a tool that I think will be really, really useful for any type of experiments. I absolutely love it. I'm being quite biased, but I designed this for me because I wanted it. It wasn't. It's not really a commercial exercise. You can check the crystals with the spectrum analyzer, and you'll see the what that looks like as well. But yeah, that's it. It's done. So I'm going to do a separate video on the case and a couple of separate videos on alignment, particularly on the variable frequency oscillators. But that's it. So hopefully you've got this far yourself, and this video has been useful. So congratulations, and I can't wait to see what you're going to do with it. Take care, and thanks for watching.